let's introduce washers. Now, to introduce this idea of washers, we're going to start with what we know. So let's start with example 3a. In this example, we're taking this parabola right here, and we want to rotate it around the x-axis. So we're going to get these circles here. So you can start to visualize what this is going to kind of look like. Once again, to try to help you visualize this, let's come right here. So here's our shape, and we've got this rotated around the x-axis. Makes this shape here, kind of like a football. So what I would like you to do is, using what you learned in the last video, I want you to pause this video and set up the integral for this shape on your own. Then come back, check your answer, and then we'll use this shape to introduce the idea of washers. Welcome back. Let's see how you did. So this is a disk, a rotation, so we're going to use our pi r squared formula because we're making circles, pi r squared. And our r is this distance here, which if we want to think top minus bottom, the top is this top graph, so we got that, minus the bottom is just 0. So I didn't add that part in. So there's my radius, r squared. And we don't need to solve it this time, it just says to set it up. So there we go. Now, let's introduce a new idea. Let's take this same exact shape, but I want to rotate it around the line y equals -1. Let's visualize this. So let's go here, and we're going to change where this rotates. We're going to say I want it to rotate around y equals -1 now. And let's see what happens. So we're taking this shape here, and we're rotating it around. And look at this shape. Now maybe you can start to understand why we call these ones washers. So if you look at the yellow dx as it moves, this is the shape that we're looking at. So there is our washer. I like to also think of it as kind of like the donut method. Creates those donut shapes. Because there's our line that we're rotating around, and we're taking this half circle shape and rotating it around that line. And that gives us this donut shape, or a washer. Now, this is a very different shape than everything we've been doing so far. So if I go back here, I have a very different equation that I'm looking at. Notice in this one, I have a big R squared minus a small r squared, where the big R is the outer radius and the little r is the inner radius. So if we go back to here, our big R would be from here to the center. We're taking that big radius and then subtracting this inner radius here. And then that will give us the shape that's left. Big R squared minus little r squared. So let's come here and try to set this integral up. It's still going to be from 0 to 1. I still have pi outside. But now I want big R squared minus little r squared. So let's color code this. My big R and my little r. Okay. Right here you can see our big R. So if I think top minus bottom, my top is my equation, negative x squared plus x, minus the bottom is a -1. Top minus bottom. Same thing that we've been doing for several sections. So that is my big R. Now I look at my little r. And same thing, I can still think top minus bottom. Well, this top line is at 0 minus my bottom line is -1. So that inner radius is just 1 squared. And that is our integral. And once again, we don't need to solve it. It just asks us to set it up. And that's going to give us the volume of that donut shape, that washer shape. The big R squared minus the little r squared gives us what's left. And then we integrate it to get the volume. So using that, what we just talked about, I want you to try C on your own. So you're going to use the same setup, just set up this integral, don't actually solve it. Oops. And go through that process of the big R minus the little r. So I'll help you out right here. Here's your big R. And here is your little r. And before I have you pause the video, just to help you visualize this shape, let's come over here and say, okay, let's change this to y equals 2. And here is our shape now. So now you'll notice the outside right here is totally straight. Here, let's move our dx through. The outside is totally straight. And the curved part is on the inside now, because when we rotate this all around, that curved part is on the inner radius instead of the outer radius. So now we get this shape. It still kind of looks like a washer or a donut, but the curved part is now on the inside of the donut, not the outside. So there's your visualization. Now I want you to pause the video and set up this integral. Ready, set, go. Let's see how you did. Our big R, top minus bottom, 2 minus 0, so our big R is just 2. Our little r, top minus bottom, is 2 minus our equation, so 2 minus the equation is our little r, and there we go. So that is it for this video. In the last video for this lesson, we'll do one more example where we look at this washer idea.